Hello, welcome back. We continue to review our textbook, Construction Materials, Methods, and Techniques, Building for a Sustainable Future. This video is about chapter 16, so we continue to review the metals, and this chapter is all about non-ferrous metals. So, upon completion of this chapter, you'll be able to select non-ferrous metals for a wide range of applications, and also you'll learn about the properties of the non-ferrous metals and how these will influence a material's performance. And we also will understand the effects of galvanic corrosion and how to design to eliminate that. So the first sub chapter here is aluminum, and aluminum is a versatile material used widely in the building and construction industry, and it's one of and in the construction industry is one of its largest consumers. So aluminum is lightweight and is a good conductor of electricity. So, and also it can be compared to the copper wire. And aluminum's conductivity is roughly 65% of copper. So please review the mining aluminum process and then how to refine the ore. And there are a few steps how to do that. So let's take a look at the electrolytic process here. There are a few charts showing the wrought aluminum and aluminum alloy designation system, as well as the breakdown of the aluminum designations. And you can see the UNS designations, the Unified Numbering System designations. We also reviewed that in the previous chapter, chapter 15, when we spoke about the ferrous metals. So a few tables for your review, please always do so because it is simply impossible to actually talk about this chart and the table in the video, but when you look at that, it will become really easy for you. There all are also temper designations, and you can see the non-heat treatable alloys, heat treatable alloys. Then also you can see the temper designation, and that consists of letters and numbers placed after the alloy number and separated from it by a dash. Aluminum castings and also natural finishes, mechanical finishes, and chemical finishes are reviewed here. So please just take a look at those charts because there are also typical applications of aluminum alloys and also the specific construction product applications. So, and also you can see the anodic finishes here. There is an anodized electrolytic oxide layer. So please review how that is done. And also there is a mechanical finish of aluminum. And you can see there are different types of that. It can be fabricated, it can be buffed, it can be directional textured, non-directional textured, and so on. So there are so many different finishes and coatings. So please make sure you review those if you need to specify those in your project. And also there is a protective layer for a finished aluminum product. Again, review those because those are different ones. And there is also a process describing the routine maintenance of aluminum surfaces, as well as joining aluminum members and aluminum products. The next metal is copper. So again, there is a history of copper. Please review that. There are properties and the production of copper. It's a few step process. And also there is a chart that shows the UNS designations for copper, brass, and bronze as well. And you can see the classification of copper and copper alloys. You can see a variety of copper fittings produced from copper alloys, and also you can see the shapes and sizes and different use of the copper products, and that includes electrical conductors, flashing, gutters, and roofing. So a few different applications. We are continuing with another metal, and that is brass. Again, same structure of the subchapter. It's the history of brass. It is the plain brasses such as copper, zinc, alloy, and tin brasses such as copper, zinc, tin alloy, and leaded brasses, copper, zinc, lead, alloy. So please review that and review different architectural bronze and other decorative uses such as grill, handrails, architectural trim, and hardware. So there are many different applications in the building. Another one is bronze and then lead. And again, it's the same structure. You can see the history, you can see how to actually deal with the alloys, how to use the UNS designation, and also how to determine the properties and different characteristics in production of the metals. Also, the chapter reviews the Turner plate, nickel, titanium, zinc, and other metals here. And the most important thing that we need to remember is to how to actually um, differentiate the metals so there is no galvanic corrosion process. And you know that there is different electrolytic potential of the metals, and there are metals with a high potential or anode, which is positive, and there are low potential, which is cathode. And those materials cannot be put together, otherwise there will be a galvanic corrosion, which we want to avoid for sure. So there is a chart showing that, and please review the galvanic series and um, the metal that is higher on the table um, of electrolytic corrosion potential will corrode more. And so, for example, when aluminum is plated with zinc and electrolytic action corrosion occurs, the zinc corrodes and protects the aluminum. And when steel is coated in zinc, it is called galvanized. So it's galvanized steel. And when it is not possible to avoid contact between the similar metals, they can be given a coat of unleaded paint or separated with a plastic or other non-conducting material. And a joint can also be caulked or otherwise sealed to keep out moisture, and actually that will eliminate the electrolyte. So that was it for our chapter 16. Thank you so much for watching. I will see you in chapter 17, and we will discuss the steel frame construction. Thank you.